Just kidding, there's nothing live about it, we're just recording. All right, today we are using explicit rules. Oop, spell much. Now, an explicit rule is special because it is like a function rule. These are like function rules. They have input and output. Okay, which for mere mortals like us makes these rules very, very wonderful to use. Computers really like recursive rules. A lot of computer formulas can be written as recursive rules, and computers love that because computers can do like so many calculations in just 1 second, right? Guess who cannot do that? Me. Okay, so I'm not a computer. I can make a recursive rule work if I have to, but this input-output function rule business is really my jam. So the difference between an explicit rule that works like a function and a recursive rule is that a recursive rule needs previous terms to find the next term. We have to know what the previous terms were to get our next term. With an explicit rule, we don't need that. An explicit rule is actually defined in terms of n instead of just using the previous term. And I'll show you a little bit what I mean in a second, because right now that just sounds very abstract. All right, we're going to make it a little bit more concrete. So here are some explicit rules. We've got arithmetic and geometric, just like last week. You can see here that my a sub 1, that's my term 1. That's a 1. A sub 1 is 4, so that's my first term in my sequence. And you can see my common difference is D right there. It's a 3. So I can just start at 4 and do what? Add 3, and then I'm at 7. And then I can keep adding 3. So my next term would be 10, and then 13, and so on. Now, if you only have to do a couple of terms, this is still probably the fastest thing you can do. Okay? Just write it out. Pretend like it's recursive and use the previous terms to get the next term. But if I asked you to please find me the 201st term, okay, find term 201st. If we had to write out this whole list, I don't know that you guys are getting in home in time for dinner tonight. You know what I mean? Like, how long would a 201, you know what I'm saying? Like, that's a long list. Do we have time for that in here? No, we don't. So what we're going to do is see that our n would be 201. For our 201st term, our n would be 201, right? I just picked that number, okay? Like if I was going to ask you to do this, I would tell you what n was. Okay, so I can do a sub 201 equals, and I'm just putting it in 201 wherever I see an n. 4 plus 3 times 201 minus 1. I just put in 201 wherever I had an n. In this spot, there was a little n, and in this spot, there was an n, right? Now, all we have to do is simplify the right side. Somebody tell me what 201 minus 1 is. Okay, what's 3 times 200? 600, now add 4.
604.
Yeah. So our A sub 201 is 604. And we did that in how many seconds? So if I only had defined like the second, third, fourth term, this might seem like more work than needed, right? But if I want to find a term that's like way out there in the future, this is a pretty massive shortcut. Do you understand what I'm saying? Okay, I understand that the phone was ringing. Do we need to go back and do this again? Okay, everybody got it? You're just like blotto on me. All right, we're good. Okay, so here is our cute little geometric rule. You can see that I have a 5 in the G sub 1 spot. That's our first term. So I start at 5. Okay, and my R, I have a 2 in the R spot. So my common ratio that I multiply by is 2. So I'm just going to multiply by 2. And I get 10. And then I multiply by my common ratio again, and I get 20. And then 40. Okay? If I want you to find a specific term, could I tell you what n is and have you put n in the power and simplify? Yeah, and then you probably like outsource that to your calculator because it might get real big real fast. Questions for me? Okay, would you like to see what that looks like? Yes. Okay. Pick an n that is above 10 and less than 20. Okay. So if I say n is, what did you say? 15. Okay, then I can say G sub 15 equals 5 times 2 to the 15 minus 1. Well, what's 15 minus 1?
14.
Yeah. So this would be G sub 15 equals 5 times 2 to the 14th. So ask your calculator what 2 power caret 14 is, and then multiply it by 5. And that's your answer. You didn't have to do 15 things, right? In a big long list. Did you get it? All right, if you don't have a calculator yet, would you go grab one? Okay, what did we get? Anyone? Okay, maybe just tell me the numbers. What did you get? 819 2 0. That's it? I kind of thought it was going to be more. 2 power caret 14 times 5. Yeah, okay, sorry that I doubted you. I thought it was going to be a bigger number. These get really big really fast. Okay, that's a big number. Not as big as what I thought. Okay. All right, we're going to zoom down to number 2, and then we'll go back up to the matching, okay? We're going to jump around a little bit. All right, I'm asking you to write the first 4 terms. 1, 2, 3, 4. This one says start at what number? 17. And what do I do to 17?
Subtract 6.
I'm subtracting 6 to find my next, which would be 11. And then 5. And negative 1. Okay, what about this one? Start at and multiply by? Uh-huh. 18. 54, right? 54. Okay, that's not so bad. Okay, I want to caution you when you're doing this on the computer, on your calculator, because sometimes what kids will do is they'll start at 11, and then they'll give me this instead, and they'll like not do this one. Do you see what the problem with that is? They're giving me the 2nd through the 5th instead of 1, 2, 3, and 4. They're giving me 2 through 5. So just be careful that you're giving me the actual first 4. Is what I said makes sense? Okay. All right, let's match these up. Now, the only thing different about these compared to yesterday is that I have explicit and recursive rules all mixed up in here together. So the recursive ones are the ones that start with A sub 1 and G sub 1. These are recursive. And the explicit ones just start with the G sub n and A sub n. Oops. Oh. All right. So all you're looking for is what number do we start on? What is our first term? And then what do we do to that number? What are we adding? What are we multiplying by? Go. All right, the first one, C. Second one, D. A and B. Okay, questions for me? Okay. Oh, there's one at the bottom, isn't there? I skipped. All right, so I'm going to show you how we have done this for recursive and how we can still do this for explicit, and then I'm going to show you the explicit superhighway shortcut. Okay? Huh? Not right now. Okay. So, I'm trying to find n. So I need to make a table where I have my n's, which are my term numbers, and my a sub n's, which are my actual terms. Okay, does somebody tell me what my term 1 is? Did someone say 12, or am I hearing things? Okay, you said 12. Okay, I've got a tiny 12. Okay. Second term is add 5. 17. Okay, add 5 again. Okay, add 5 again. Add 5 again. You see it's just going 2, 7, 2, 7, 2. You see it? That's kind of fun. Okay, so 4, 5, 6, 7, 8. So, what is n for the value 47? 8. N equals 8. I had to find n. All right, now, let's say that I'm some evil witch, and I tell you, I don't want you just to find n for the value 47. I want you to find it for 157. Dun, dun, dun. I'm like, that table is huge. You didn't give me enough paper for that table, right? So we're going to say find n for 157. So we're going to treat this like a function rule. 157 is our output. We are going to replace a sub n with 157. Does this look familiar, like what we did with Mr. Woinitz's cookies? Okay, so I've got 157 equals 12 plus 5 times n minus 1. And now I just solve for that cute little n. How do I undo adding this 12 to both sides? Subtract it away. So what's 157 minus 12? 145 equals 5 times n minus 1. Am I allowed to distribute? Yes. Is that my only option? No. Could I divide 5 away from both sides? Divide both sides by 5? Okay, so please ask your calculator what 145 divided by 5 is. 29. So 29 equals n minus 1. How do I undo the minus 1? Add it over. 30 is n. So if you're looking for a term that is sufficiently large or sufficiently out there in your sequence, is this a shortcut? Yeah. Is it a shortcut if you can do it within the first 10? Maybe not. So you kind of have to decide what the best use of your time is. Questions for me? Okay. Let's do this one. All right, what is this one asking us to find?
A number.
The which term? The fourth term. So I'm going to find 1, 2, 3, 4, and then that fourth one is going to be my answer in a box. Right? Ooh, what happened to my box? Sorry. All right, go ahead and see if you can find it. What do you start at?
36.
Okay, 36. And then what's my next term?
18.
18, and then?
9.
And then,
4.5.
careful. Ooh, good, 4.5. You guys are the first crew that didn't say 3. So my G sub 4 is 4.5. That's my answer. Okay, go ahead and do the next one. I'm starting at 25. And then I'm adding 3 to get 28. Oh, did you say 34? Okay, so my A sub 4 is 34. Questions? Okay. This should kind of feel like review. Do we need to do this one? It is like the one we did at the bottom of the front page. Can we skip it?
Yes.
Okay. We're going to come back to the Daffy problems because I don't know that we need them. If we need them, they're there. If not, not. Okay. This could be the end. So we just have to focus. All right, do you guys have the little present that I gave you on Friday? This little guy? This little half sheet. Could you get it out, please? Get one too. Okay, so I'm looking at my little half sheet. Okay, I'm seeing my general formulas. Remember, they go explicit, recursive, right? So I'm writing an explicit rule this time. So my explicit ones are my first one and my third one. So it says A sub n equals my A sub 1 plus, do you guys see how the D is written after the parentheses? You're not going to get it wrong if you write your D after your parentheses. But if your D is negative, it gets really confusing because it looks like it's subtracting with the parentheses and not multiplying with the parentheses. Do you understand what I'm saying? So I'm going to ask you to write it in front. If you forget and write it in the back, it's not going to be a big deal because that's how the paper shows it. But all of your ones on your assignments and everything, it's written in front like this. All right, the other one is G sub n equals your G sub 1 multiplied with your R, and then your R is raised to the n minus 1 power. Oops. That just looks exponential, doesn't it? You see how n is in the power just like x in an exponential function? This just looks linear, doesn't it? Yeah, okay. All right, let's do this. I'm going to do B and C with you, and then you're going to do A and D, okay? Look at B. What have we got going on here? It's subtracting 20 every time, so we have a common difference of negative 20. Okay, our first term is 100. So we are going to put in the 100 for the A sub 1, and we're going to put minus 20 in for D. And that's basically that's all we're going to change. Everything else we can just copy from our rule. So this one is arithmetic. A sub n equals our, go ahead. 100 minus 20. Good. That's it. It's a wrap. Okay, now we're going to do C. What kind is C? Geometric. Yep. Okay, so we're going to use this rule. G sub n equals, what's my G sub 1? 80. Okay, and then I'm going to put my R multiplied with the 80, and the R is getting raised to the n minus 1 power. What's my R? Okay, if I'm dividing by 4, how can I change that to multiplication? Correct. So my R will be 1 over 4. Remember, my common ratio is defined as what I multiply by, not what I can divide by. Okay. You guys ready to try A and D? Okay. Okay, somebody tell me what A is. It's geometric. Okay, does someone want to come up and write it? Come on down. Yeah, you can use it. Oh no, it's harder than it looks.
I don't like this board. Wait. I just had wrong. I'm not gonna do that.
Hold on. There you go. Perfect.
I couldn't remember what I put on my plate.
So that's why sometimes, yep. All right, does anyone want to try this one? All right. Oh, I'm going to have to let you guys fight it out.
You? Just let me do it.
Does one of you want to write the name and the other one want to write the rule? I'll let you fight over who has better handwriting. Okay, you guys can both write at the same time, but you can't one of you write and the other one erase, so nobody gets to make any mistakes. And don't hit it with your sleeve. Yeah, that looks good. All right, how did we do? Okay, do we need to go back and do the Daffy problems?
No.
Are we ready to get some work done today or what? What?
Yeah, we can work.